Hello, ladies and gentlemen. Today we're going to start talking about areas. So understanding area and using area formulas and when they apply to different shapes. So for this, you're going to need your calculator, something to write with. I would say either a pen and a pencil would be great because you're going to be taking notes and marking up things and you may want to erase. Your notes, obviously, is where you're going to be writing these things. And that formula sheet that you got in class is going to be the place where you want to start writing some of these formulas, okay? So on this idea of area, we're talking about the space inside of a shape. So it's measured in square units. Perimeter is around the outside of a shape. Like if I was going to put fence all the way around this arrow like this, we'd measure in how many inches it is from here to here, or how many centimeters it is from here to here. But when we're talking about area now, we're talking about filling in a shape with little tiny squares. So how many square units would fit inside this arrow shaped shape here? So how many square units are going to fit inside? So it's important when you label things that you're always remembering to talk about an area measurement and not just centimeters or feet, but instead centimeters squared, feet squared, that sort of thing. Okay, the units are different when we go to area because the idea is different. So on your formula sheet, let's get down some area formulas, common ones that you may already know, maybe some new ones here. So area of a square. I hope you remember that the area of a square is either base times height, but in the case of a square, since the sides are all the same, you could just call it side squared would also work. The side length times itself. In area of a rectangle is a common one that you probably know already. Area will equal base times height. Sometimes we refer to this as length times width, but you want to be careful because it's really that height measurement that we're going to use more often than just how wide something is, okay? Area of a parallelogram. Parallelograms are just a slanty version of a rectangle like this, so they don't have 90-degree angles. And if we take a look at a parallelogram and we cut off that little triangle on the side and tape him over to the other side, he does make a rectangle. See that? Okay, check that out in case you missed that. Let's do that again. This is a parallelogram. If we cut off the little triangle over here and place it over here, he just is a rectangle, okay? So when we do the area formula of a parallelogram, it's the same as if it was a rectangle, except the area, make sure that you know, is base times height, not length times width, okay? In area of a triangle, we've used several times. If we think about parallelograms or rectangles and we cut them in half and take away half, that's what a triangle shape is. That's why it's base times height divided by 2, or 1/2 base times height. So if we find the area of a shaded region, if we're going to find the area of a shaded region like this, take a look at this blue region in here. This blue shape, if you were going to classify him or talk about him as what he is here, how would you label that blue shape there? To me, he looks like a parallelogram. And if we think about parallelograms, area equals base times height. What's the base of my parallelogram? 6. So I'd put 6 in here. How tall is my parallelogram? Be careful to not think 12 here, okay? Because how tall he is from this base up to this one, that's what this measurement out here is for. That's giving me the height of my parallelogram. So his height is 8. So the area, total area, would be 48. And I'd say 48 units squared, okay? It's important that you put 48 units squared and not this, okay? 48 squared is not the same thing as 48 square units, okay? The squared is on the units and not the number itself. So 48 square units. Now that's only one way that we could have found the area of this. Sometimes people don't like the way this thing is turned, and so they want to redraw it without that turn in there, and that's totally fine if you want to. If this is 12, inside here would be 4, over here would be 6 on the slanted side. And if you want to think about him redrawn like this, he's still a parallelogram, okay? We're just going to redraw him so that he's, sitting on that big longer side, like where visually our mind kind of likes him that way, okay? So if I was going to find the area another way, I should still get the same answer. What would the base be of my parallelogram? Well, if this is 12 up here, this will have to be 12 down here because in a parallelogram, opposite sides are congruent. So 12. And how tall is my parallelogram? That's what that 4 measurement is in there for, okay? Not the 6. 6 is on a slanted side. 4. So now if I take 12 times 4, guess what I get? It's 48 square units. So no matter how you look at it, or you can say unit squared like I did on the last one, how you look at it, it doesn't matter. But the formula is still going to be the same because it's a parallelogram. We always have to use that same formula. Okay, what if we switch up the word problem a little bit here? A triangle has an area of 126 centimeters squared and a height of 14 centimeters. What is the length of the base? I would make sure to write this one in your notes. Okay, we only have a couple examples today here, so I'd expect they'd be there. A triangle has an area of 126 centimeters squared and a height of 14. What is the length of the base? So this means we have to solve for a missing measurement. We already know the area. Area formulas are places where you can plug in numbers. So if I think about my area formula for a triangle, it's base times height divided by 2. Or you can use area equals 1/2 base times height, same thing. Okay, and if I plug in the numbers that I know, 126 is the area. Okay, it says it has an area of 126. And it says it has a height of 14. So I'm going to put b times 14, and then divided by 2 is just a part of the formula. And we need to try to solve for the base right here. So we need to try to figure out that base. How would we do that? Well, let's undo parts of this formula here to get b alone. See this dividing by 2? How do we undo that? Multiplying by 2 is the opposite of dividing by 2. So then that would cancel and I'd have b times 14. And I'd have 126 times 2, which is 252. So 252 equals b times 14. And then if I divide by 14, 252 divided by 14 is 18. So the base is 18. Now labels, is it 18 centimeters, 18 square centimeters? For this one, it would be 18 centimeters because the base is a length measurement. It's not an area. We already had an area measurement. Okay, so this idea of using area formulas to solve for missing things is pretty common. And last but not least, one to get into your notes on a big application of this. Okay, area is one of the most widely applied ideas of geometry. Okay, so being able to compute area formulas is going to be something that comes up in your real life. Really, I'm not even kidding. So, grass seed. Let's say we have to calculate how many pounds of grass seed I should buy and use to cover this lawn. Okay, a pound of grass seed covers 1,650 square feet. So when you chart out your lawn or land or even your house plan, the chances are it's not a perfect rectangle, a perfect square. It's going to be a little bit irregular here. So what we need to do is find the areas of each of these pieces and add them all together so that we can find the total area. That's our plan. Okay, that's our plan. So the plan would be to find the total area here. Area of the triangle over here on this right triangle, okay, area of this right triangle, area of the parallelogram right here, and area of this triangle over here. Now it seems like a simple plan, but there are some things we need to know and remember in order to be able to find this area. So let's start on this left-hand side of your diagram here. Let's start on the right triangle over here. This triangle right here. If I just grabbed him and took him off the picture and turned him a little bit, so I put the 20 on the bottom like this and the 52 on the side, we need to find the area of that triangle. We need to find out base times height divided by 2, that's the area formula, b times h divided by 2 for that triangle. What's the base? Do you see it? It's 20. I can see that. Do I have the height of this triangle? Because I'm going to need it to plug into that formula. And the answer to that question is no. 52 is slanted. It is not the height. I need to find that height right there so that I can use it to find the area of my triangle. Now remember we said the Pythagorean theorem was probably one of the most important things you ever learn in geometry? Here's where it keeps coming back. We need to use the Pythagorean theorem to help us solve for x. Okay, so how will we do that? 20 squared plus x squared equals 52 squared. And we solve for the x using the Pythagorean theorem. So I'd have 400 plus x squared equals 52 squared, which is a big number here, 2,704. We subtract our 20 squared, which is 400, and then we take the square root of our remaining. We're solving for that x value. We just found out that this x is 48. Okay, 48. So I know this measurement right here, I'm going to add that to my original picture, is 48. So can I find the area of that triangle? Answer now, yes. The base would be 20. The height of the triangle is 48, all divided by 2. So the area of that one triangle is 480. Okay? Now we're going to move on. I need to take this area and I'm going to add it to other areas here before I'm all the way done. Let's move on and find the area of the parallelogram here. The parallelogram in the inside. So now we're focused on the inside here. Parallelogram has an area formula of base times height. What would be the base measurement here of my parallelogram? It would be 80 because it's the exact same as what's on the top. Parallelograms have opposite sides that are congruent. How tall is my parallelogram? That would be a measurement straight up and down. How tall would that parallelogram have to be? Hopefully you see that that parallelogram would also have to be 48 tall, just like my triangle out here. That's this measurement, and that would be the same if I measured on the inside right here. So 48 is how tall that parallelogram is as well. So we would take 80 times 48, base times height, and that gives me a parallelogram measurement of 3,840 square feet, just for the parallelogram. Now let's go to the triangle at the end. Triangle right here. One more triangle and then we can total these up. Area of the triangle. Area of the triangle formula again. Base times height divided by 2. What's the base of this triangle? That'd be 40. How tall is this triangle? We don't have that measurement in our picture. Do we need to do Pythagorean theorem again, do you think? Perhaps we could. We could say that this is 20, and we do 20 squared plus x squared equals 52 squared. But you know what? We've already found that height. It was the same as the height over here, same as the height over there. So we know he has a height of 48, so we're going to go ahead and use the height of 48 divided by 2, and then we can calculate the area for just that triangle. 960. So now if we do a total, let's total them all up. 480 plus 3,840 plus 960. Total area is 5,280 square feet. Okay? So now if we know that a pound of seed covers this many square feet, how do we find out how much seed to buy? We would take that number and divide it by 1,650, and it tells me that I have to buy at least 3.2 pounds of seed. Okay, we'll divide that by 1,650, and I get 3.2 pounds of seed. So area formula is not so difficult to work with, but sometimes when your diagrams get complicated, we're going to need to take several steps to solve a problem, and that's okay. Just developing a plan and working through it, that's the key idea. Thank you for taking good notes, and I will see you later.